My name is Dr. Adiv Paradise. I study the climates of alien worlds, both what they can tell us about life out there, as well as our own climate here on Earth, both in the past and present, and in the future. In order to understand climate change, I like to take a step back and think about how does the climate actually work. So my favorite analogy is that of a shower or a bathtub. You can think of the shower head as like the sun. Light enters the atmosphere much as water enters the tub. Some heat builds up in the atmosphere, like water fills the tub, and then heat exits to space, like water leaving the drain. The rate at which the water drains from the tub depends on how clogged the drain is, and anyone who's ever had their shower drain clog a little bit knows that even just a small clog can lead to a lot more water around your feet. The same is true with the climate. The more greenhouse gases we have in the atmosphere, like carbon dioxide, the less heat can make it to space and the more heat builds up in the atmosphere. So what happens with climate change is as we add CO2, we are making it harder for the Earth to lose heat into space. And so the planet gradually warms up. Of course, the climate is actually a lot more complicated than just a shower or a bathtub. There are other things to keep in mind, like in reality, the drain is not directly beneath the shower head. The Earth absorbs most of its light near the equator where the sun is strongest, but loses most of its heat near the poles. So it's like water sloshing around in the bathtub. You have to move heat around the planet as well. And part of the reason that scientists have shifted from calling it global warming to calling it climate change is that for most of us, the biggest effect is not necessarily going to be just a flat increase in temperature. It'll just be that things are different. Rainfall patterns are different, wildfires are more common, there are more droughts, more heat waves, more cold snaps. Because one of the biggest things that changes as the planet warms, because it warms differently in different parts of the planet, the way the atmosphere moves, the way heat is moved around, all of that changes. Climate change is caused primarily by humans burning fossil fuels and emitting carbon dioxide and methane into the atmosphere. Most of the sources are things like power plants that burn coal or natural gas or oil, as well as things like transportation, cars and planes and ships that burn fossil fuels, and also things like concrete, steel, agriculture. All of these things can release carbon emissions into the atmosphere. Now, we are not headed for any kind of climate state where the Earth becomes uninhabitable. You may hear people say, but carbon dioxide has changed before. This is true. And even where we might end up if we do nothing is not outside the realm of what Earth has been before. The really scary thing about climate change is that it's happening very, very fast. We are adding carbon dioxide to the atmosphere at around 50 times the natural rate at which it's added by volcanoes and other natural processes. One possible solution to climate change is to geoengineer our way out of the problem by changing the Earth's atmosphere. This is completely feasible, but we have to understand that there are many different things that we mean when we say geoengineering. Technically, we're already geoengineering the climate. We've increased the amount of carbon dioxide in Earth's atmosphere by 50% since pre-industrial levels. When we talk about geoengineering, we usually mean something a little bit more than that. One of the most attractive proposals that a lot of people are interested in is this idea of could we just add something to the atmosphere, something else, a little bit of dust in the upper atmosphere, and reduce a bit of incoming light. And this would cool the planet. It would be the equivalent of turning down the water pressure in your shower in order to make the water level in the tub go back down. That would definitely work. It would reduce the amount of heat in the system, and it would bring the planet back down to the temperature that we're used to. However, as you might realize with the shower analogy, when the water pools up in the tub, your feet notice it first. When you turn down the water pressure from the shower, your head notices it first. So if we consider a geoengineering solution like adding dust or soot into the stratosphere, into the upper atmosphere, we need to consider, are we actually fixing the problem? Are we going back to what we were used to? Or are we just continuing climate change, but a little differently? One of the ways that we can maybe understand the climate a little bit better and determine if a solution like that is actually suitable is to try to understand climates a little bit more generally. So when we ask these questions, what we're effectively asking is, what would the Earth look like if something were a little bit different, if we changed one of the variables? Now, when we do that, we're no longer talking about Earth. We're talking about a planet like Earth, but a little bit different. And that's the same thing that we do when we ask about the climates of alien worlds. My research has focused on studying exactly these climates. What happens if we change some of the variables? If we adjust some of the conditions that determine Earth's climate to understand what it might be like on a slightly different planet. So as we study the different ways that Earth-like planets can have climates and can be habitable or can be less habitable, this helps us to understand, how do these systems on Earth work? What are our models uncertain about? What are they sensitive to? What assumptions are we making that may not necessarily be good assumptions? In my opinion, this is a bit of a risk. We need to carefully think about what the consequences will be and who it will hurt. One of the challenges is that while we understand the climate fairly well, and our models do a very, very good job of predicting climate change, we don't understand all the parts of it particularly well. Some of the things that we're the least certain about are things like clouds and how aerosols and dust particles move in the atmosphere and how they affect the climate. The geoengineering proposal to cool the climate by adding dust and soot to the atmosphere works by playing with one of the variables that we understand the least. So we need to do a lot more work to understand if this will actually cause even bigger problems or just different problems for different people. Because the thing to remember is that climate change is a human problem. There are human lives that are affected. And so any solution we choose has to be one that will help people and that will help reverse some of the harms that they're already encountering.